channel dedicated to exploring the wonders of the cosmos. We are delving into the intriguing subject of how astronomers calculate distances in space today. I'll begin by going over some important terminology, and Kirtan will take over and go over the techniques. Let's begin. Moving on to light year. This is the distance that light travels in 1 year, which is about 9.46 trillion kilometers or 5.88 trillion miles. It's used to measure the vast distances between stars and galaxies. Next up is astronomical unit. This is the average distance between the Earth and the Sun, approximately 150 kilometers or 93 million miles. It's handy for measuring distances within our solar system. Parsec is about 3.26 light years, and it's often used by astronomers when discussing even greater distances. It comes from the term parallax of 1 arcsecond. Understanding these terms is essential because they help us grasp the scale of the universe. Now let's talk about why measuring distances in space is so important. Over to you, Kirtan.
Space is unimaginably vast. For example, the distance from Earth to the Moon is about 384,000 kilometers, but that's tiny compared to the 150 million kilometers to the Sun. And even that is dwarfed by the 4.24 light years to our nearest star, Proxima Centauri. Measuring these distances helps astronomers understand the size of the universe, locate celestial objects, and even track the expansion of the universe. So how do we measure these incredible distances? Let's dive into the methods. First up is parallax. Have you ever held your thumb in front of your face and closed one eye, then the other? Your thumb seems to shift positions. Astronomers use the same principle by observing a nearby star from 2 points in Earth's orbit 6 months apart. They measure how much the star appears to shift against the background of distant stars. The smaller the shift, the farther away the star is. This method works for stars up to a few hundred light years away. Using d is equal to 1 over p, we find a star's distance in parsecs, where p is the parallax angle in arcseconds.
Next is the standard candle method. Some stars, like Cepheid variables, have a predictable brightness pattern. By observing how bright they appear from the Earth, astronomers can calculate their distance. Another example is supernovae, which are like cosmic lighthouses. Their peak brightness is so well known that they can be used to measure distances to galaxies millions of light years away. Finally, we have redshift. As the universe expands, galaxies move away from us and their light stretches to longer wavelengths, shifting to the red part of the spectrum. The farther away a galaxy is, the faster it's moving, and the more its light shifts. By measuring this redshift, astronomers can estimate distances to the farthest part of the universe. However, the redshift of distant galaxies due to the expansion of the universe is described as cosmological redshift, which is related to general relativity and not simply the Doppler's effect.
Did you know that if you stacked coins from Earth to the Moon, you would need about 10 billion of them? And that's still only 400th of the distance to the Sun. Here's another cool fact. The light you see from sun stars started its journey way before humans even existed. Cool, right?
So, to recap, astronomers use parallax for nearby stars, standard candles for medium distances, and redshift for the farthest reaches of the universe.
Understanding these methods not only help us map the cosmos but also gives us a sense of how vast and incredible the universe is. Don't forget to like, subscribe, and hit the bell icon for more cosmic content.